So this is information specific to the project. I would also encourage you to read the implementation guidelines. So basically what's required, and I am specifically talking about Java graphical user interface because originally the course was designed for people who take Java, actually 2 Java courses before taking this class. But realizing that a lot of you have just plain C background, it's okay to work on it using C. So this is not Java specific, but essentially more information about this. But this is those 3 sets: the business requirement, which is our initial description of the system to work on, our challenge, if you will. The development guidelines and milestones I discussed with you, and then these are implementation guidelines, which are just set of minimal requirements of what you should be able to present at the end. So those 3 handouts are, if you will, the direction in which we're moving with specific to the semester project. Now, I chose to use this elevator problem to be our challenge. Simply because I'm finding more and more that people come to job interviews, especially programming folks, and they're asked about the elevator problem. Essentially, it goes off as, you come to a job interview and someone is asking you someone's asking you, okay, if you had a building with like a bank of elevators with like 3 elevators and 15 floors, how would you design a system which, controls the traffic of these elevators, depending on the visitors to the building, the riders, the floors, all the controls that are available? How would you manage something like this? And if you have not taken any look at a similar problem, right? And a similar problem could be any traffic system, for instance, a railroad traffic control. If you spend like 5 years working in the railroad traffic control, you'll be extremely familiar with traffic control principles and essential parts of it. But you have never experienced any of it, it can be really challenging and a bit frustrating at the job interview. So this is a really good problem to look at in class, because it involves surprising number of challenges and decisions to make. So this is going to be an interesting problem to look at. Right, so this is one of the classical problems, and so instead of working on a small business application, which we will be reviewing in class anyway, that's the challenge for us to work on with respect to the semester project. And of course, there will be lectures. Okay, so there is now such an abundance of material on system design, formal system design, specifically using UML, Unified Modeling Language, in system design, that I will be, my plan is to, instead of recording a lot of lectures, spending all the time on UML, I will be just posting links on great resources that exist on YouTube and elsewhere, so you can just watch it on your own and learn the principles and learn what you should know. And we'll just probably scale down discussion on those things a little bit, but we're going to have a fair discussion on UML. And so this gives us a chance to focus more on software, on your software skills, on actually doing some work hands-on with the code, right? So that's just my hope, right? So anyway, we have this schedule, and I tried my best to give you this, tentative arrangement of weekly type of activity, right? So that kind of reiterates a little bit what we talked about already regarding the semester project, and you can see it should correlate with with the set of topics. But what I have not mentioned yet is that we're also going to talk about design patterns. Design patterns is a very rich topic, again, which is extremely popular at job interviews, that people come in and they're challenged by, someone would ask you, are you familiar with any of the design patterns? And you should probably answer yes, right? If you answer yes, you may be asked, okay, what kind of design patterns you're familiar with, and you should name a few. Like, for instance, singleton and proxy and decorator and adapter and other whatever. There are probably hundreds of design patterns that some people could name. I could name only a few, but if I have to, I do my own research on this and refresh my skills. But we're going to go over some essential design patterns, and design patterns are prepackaged solutions to some challenges. Right? So, for instance, if you want to remotely start your car using remote control, and you were asked to write software that implements that remote car start system, what would you do? And interestingly, you could dig into design patterns and find prepackaged solutions to something like that. And you say, oh, maybe I should pay attention to design patterns and learn them, right? So it's a big topic, a very interesting topic, because that's yet another chance for us to look at both design, very, very briefly, look at design, and then look at the actual solution. The solutions, most of the solutions will be done in C++. Because C++ is a common ground between C and Java, right? So that we can use some classes in C++, very simple use of classes, just formal packaging of data and functions or methods. And we're going to actually see solutions to these design patterns. So this is the another part that we need to discuss. All right, so let me actually maybe just sort of like highlight a little bit of what we talked about so far, right? So I guess number one, let me just maybe write a few of these things, right? So number one, we said semester project, right, we're going to work on. So that has milestones, right? The work on these milestones requires teams. We're going to form teams or individuals, right? But hopefully teams. Number two, the set of topics, right? The actual things that supposedly we will learn in this course, right? So I mentioned functional specs. Functional specs, what they are, and they're primarily like a collection of use cases, essentially things that can be done with the specific system. Extremely important. Extremely important. I would say that this is a key to success. A set of use cases is a key to success to your project. It's either going to be really frustrating or really successful. And the success depends on how well these use cases are written, documented, understood by everyone, and they actually present no big surprises down the road. Right, so this is very important. And as we begin to explore the use cases, we're going to use the UML, right? UML, number 3, Unified Modeling Language, which basically allows us to create diagrams like this, right, to represent ideas, design patterns, relationship between parts of the system, the actual distribution of components of the software. And we're going to start with very simple UML diagrams that look like this. Basically, a user or actor that can do things in the system like this, which is a set of use cases. This is like use case 1, use case 2, and use case 3. Surprisingly simple idea of this diagram has an enormous success with both programmers and users of software. So this is UML, and there are other things to say about UML. Essentially, there are different types of UML designs, like class diagrams, which is a structure, use case diagrams, which basically description use cases. This kind of goes together with this set of use cases. We can also use use case diagrams here, and eventually we can also work on state diagrams, which look like this, that your system can be in different states, and you can go from one state to another state, back to this state, visit some other state, go from this state back to the same state, and so forth, right? So state analysis is very important because, surprisingly, a lot of things have very well described states, okay? So, for instance, an elevator, it can be moving, it can be stationary, it can have doors open, doors closed, it can be taken off service for maintenance, and that's just a handful of states that perfectly describes what it should or should not be able to do in each state. So understanding of states, thinking about objects with states in software is really important. So that's something that is going to be part of our discussion, obviously. So we mentioned UML, and number 4, right? Last but not least, the actual programming, right? Hands-on code writing, right? Writing code, or we'll say using your favorite programming language, right? What's your favorite programming language? You should decide, right? I can, without any hesitation, I can say that my favorite programming language is C++ because it gives you so much flexibility. Many people will say JavaScript. Probably most people will say Java because it's easy to use it and it's very reliable and has also exceptional performance on both client side and server side, and so forth. So anyway, it's also possible to use C to write adequate code which will be using object-oriented design guidelines. But it's a little harder, but possible. So everything is to be discussed.